Hello everyone, myself Vahita, Assistant Professor CSE Department from Rohini College of Engineering and Technology. I am here to explain a few concepts of the subject CS8601 Mobile Computing. We are dealing with Unit 3, that is Mobile Network Layer. The topic discussed here is proactive protocols, that is also called as table driven routing protocol. The objective of learning this is to know about the concepts of destination sequenced distance vector routing. So first let us know what is proactive protocols or table driven routing protocol. So it maintains the global topology information in the form of tables at every node. Okay, so topology is nothing but the arrangement of the mobile devices in the case of ad hoc networks. So each node will be maintaining a table. So these tables are updated frequently in order to maintain the consistent and accurate network state information. Example is Dsdv, WRP and star. So this Dsdv is also called as destination sequence distance vector routing. So it is based on the proactive method and it is an enhanced version of the distributed Bellman-Ford algorithm or distance vector routing protocol. It adds two things for this. The things are sequence number and damping. So the sequence number is nothing but each routing advertisement comes with a sequence number. So within ad hoc networks, the advertisements may propagate along many paths. So these sequence number help to apply the advertisements in the correct order. This also avoids the loopings in the network. And considering about damping, the transient changes in the topology that are very in short duration that should not weaken the routing mechanisms, and unstable changes in the topology are not forwarded. Example is ad hoc network. So this is the example for ad hoc network. So we have 5 nodes. For each node N1, it maintains a table that contains the next hop for the towards this node. The metric is number of hops, the sequence number, and the time at which the path has been installed first. Okay, so that is given in the table following. So this is the table which explains all that things. Destination is the nodes which will reach to the next hop is the other node which we are going. Then metric is number of hops, sequence number is already we have told about that sequence number, and install time is the time of arrival. Okay, so important steps in the operation of Dsdv. So here each router, or it is also called as node in the network, collects the routing information from its neighbors. So after gathering all the information, the node determines the shortest path to the destination based on the gathered information. So it takes only the shortest path after gathering all the information. So based on the gathering information, a new rating table is generated. The router broadcasts this table to its neighbors. On receipt by the neighbors, the neighboring nodes recompute their respective routing tables. So this process continues till the routing information becomes stable. So it always goes on changing. All the routing tables gets updated as soon as it gets the information from the neighbors. Okay, so routing is divided into two parts. So routing is divided as intra-zone routing and inter-zone routing. The intra-zone routing is first the packet is sent within the routing zone at the source node to reach the peripheral nodes. So inter-zone routing is the packet is sent from the peripheral nodes towards the destination node. So in the considering the diagram which is following, the routing zone of S includes the nodes A to I, but it does not include K. Okay, so the nodes are divided into peripheral nodes and interior nodes. These peripheral nodes are the nodes whose minimum distance is less than the radius. So that we call it as the peripheral nodes. Okay, so considering in the diagram which is following next, we are showing about the interzone and intrazone routings. So all these are the interzones. The interior nodes A to F are the interior nodes, and nodes G to J are the peripheral nodes, and node K is outside the routing zone. So within the zone, table driven is used. Okay, so outside the zone, on demand route discovery is used. Okay, so the procedure followed in this is the source first sends a route request packet, that is the RREQ, to the border nodes of the zone. So it contains its own address, destination address, and the unique sequence number. each border node checks its local zone for the destination. So if the destination is not the member of the local zone, then the border node adds its own address to the route request packet, that is RREQ. In that packet it adds and forwards the packet to its own border nodes. Okay, so when the destination node is reached in this process, a route reply, that is RREP, is sent on the reverse path back to its source. The source saves the path which is mentioned in the route reply to send data packets to the radius. Okay, so these are the questions